Hello friends, this is Kamal Sarma. I produce 5 videos altogether until now on structural engineering. And this video will be a recap of all the 5 videos earlier because there's a gap for a few months and I was really busy, and also I had little hard time to find a good sound system. Hopefully you can understand what I am talking, and you should know that structure is not a very difficult subject. Only thing that you should understand it fully. You should see the holistic view of the structure. That means you should see the complete picture. So to know the complete picture, as because I'm telling you, it's a revision, it is a recap of what I said earlier, you should know what structure is. Structure is something human built. Okay? Human make or construct a structure. And so first thing is the human made structure. Is a human made. Second characteristics of structure is it should serve some purpose. That means it should have a purpose. What are the purposes? That means it's a building. You stay inside. Bridge to cross a river. Tunnel to go through a mountain. Or water storage, water retaining structures. Similarly, retaining wall. All these are structures. But you have to design and construct the structure. Design means, what is design? Design is finding the appropriate sizes of the members. That is your design. And to find the appropriate size of the members, because if you do not choose the right size, then what will happen? The structure will fail. So that means, but you should not make it very big. Also, there is a problem there. One basic problem is the economy. You cannot spend a lot of money on a structure to build. So the third one is your economy. You cannot put a lot of money to construction to make it bulky, make it very heavy. No, members should be, all the components should be optimum size. Okay, but what it has to do? It should be safe. And it should not have sufficient deflection, mostly. Deflection and vibration. These are the two main things. It should be safe. It should not collapse. Understand? So, our main purpose to satisfy these two conditions, safety and not too much deflection. The too much deflection makes the people nervous. Okay? If a driver drive above a bridge, if the bridge deflects too much, even the structure is safe, nothing will happen, but still he gets scared. He'll be afraid to go again. Similarly, if the building is swayed that too much in a wind, in a tall building, multi-story building, then also the occupant will not feel secured. So these are the things you have to consider. Vibration or deflection at the top. Okay? And safety is important thing. You should consider all the time if the structure is safe or not. And out of this safety, it is come a strength design. You have to find the member sizes in such a way it is safe. It's called, it should have sufficient strength to be a structure. And another second thing is the deflection or vibration. So this is your service ability. These two conditions always to be satisfied. Strength design, strength and the serviceability. Serviceability means if the people occupying or using the structure is feeling safe or not. Okay? But why we need the strength? For what purpose? You see, all structures, whenever you build some structure, it is subjected to some loads. Loads coming from what? Load coming, one comes from your dead load. That is the self weight of the structure plus anything permanently attached to the structure. Because it has to carry its own load first. Then it can carry the other loads. That is the point. Second thing is your live load. This is called dead load. Dead load. Okay. And there are other loads also. These live loads comes from how you use the structure. Suppose if you are staying or dwelling, the load is different. It's called live load. The live load is temporary. It may stay there, it may not be there. And the live load in the storage building is more than a residential building. Or the office building may be more, or library, it will be more than that in living in a residential building. That is the point. And the live load for the bridge is also different. Bridge live load is the vehicular load, the truck load. Okay? Then other loads are your wind load, then you have earthquake load, then you have got snow load, if it is a very, very cold area. There are so many loads. All these loads are prescribed in or given the values in, except the dead load. Dead load is a different story. But all the loads, the values of all the loads you can find the practicing code, design code. So the dead load is always the volume of the member, volume of the structure multiplied by the unit weight. You have to multiply the unit weight, the volume, then that will give the weight. Okay? So these are all the loads, and when you apply all these loads, when they apply on a structure, then some internal forces develop. That internal forces I discussed in my earlier videos. Those internal forces are, there are 4 different internal forces developed. 4. One is direct forces. They are axial forces. That means axial forces means it acts through the axis of the structure. Suppose if you have a member, when the force is acting, if it is axis, if the force is acting along this axis of the member, it is the direct forces or axial forces. They might be, if the arrow is outward, it is tension. And arrow is inside, the compression. You see, this is pushing inside. All the molecules here are compressed. It is called compression. And this is tension, pulling up apart. So this is the direct forces, the number one. I told you that there are 4 different forces developed. 4 different forces, they are developed internally. Because of the external load. When external load acts on a structure, this is the structure, say, acts on a structure, some forces develop inside these members. They are, first one is direct forces or axial forces, tension and compression. Second one is your shear force, shear. Third is your bending moment, bending. And fourth one is your tension or torsion. I described them in my earlier lecture. So these 4 forces, when it develops, that forces per unit area. Okay, this is called stress. Sometimes you written as F, sometimes as a sigma. So this is nothing but in direct forces, it is easy to find. If the P is the axial forces developed divided by total area of the cross section, that will give you your axial, the stresses, tension or compression. But for bending, it is slightly different. Shear also slightly different. We can discuss it later when it comes into picture. That means what is the shear stress, bending stress, stresses due to torsion, and the axial is very easy. Now, these always you think that you should consider that the structure is a combination of components, members. Okay? Combinations means, suppose if you have a building, building is something like this. Building is something like this. This is your foundation. This is your beam. This is column. This is also beam. And this top part is your slab. Now, these members are connected. Here, you see the beam is connected with the column. Here, column is connected with 2 beams, like that. There are 2 different connections. One is fixed. The connections of the components Connection of component one is fixed, another is hinge. I told you in my earlier lecture that fixed means, fixed is the one that means if two members are connected, suppose this is one member, this is another member. If the angle between these two remains the original angle after the deflection, suppose some forces is applied on this side, if the angle between them remains same, then that is fixed. That you can see in the residence or in a building. They are concrete. Buildings are mostly of concrete. The columns are concrete, beams are concrete. Those points, when you touch the concrete, what happens? They form a fix. They form a friction. They are fixed. They cannot rotate against each other. They're always there. So this is your fix. This type of, I mentioned earlier, this type of structure when connected, they are called frame. That means they are moment resisting. That can take moment. There is another kind of connection I mentioned earlier. They are hinge. That means they can rotate. If there is an angle between them and 90, they may rotate. When deflect, there are some angle there. But not like this. When it deflects like this. This angle remains the same if you put some glue. Okay? This is called fix. When you fix it, then something like this. When you fix it, in the whole time, suppose in your hand, one thing, this duster or this eraser. So if you put pressure there, moment there, you will feel the force there. That force which is developed at the fixed end to prevent the rotation is your fixed end moment. The moment developed is fixed end moment. Okay? So that resists the rotation of the member at this point. But here, when you do not have that fixity, this joint is allow this member to rotate. If you put a load there, this is the difference. They do not. These are frame, and when this type of structure is there, what we do to take the moment, suppose there is a lateral force there, we provide a bracing. And this type, when what happens, this force is transferred to these members like this. Okay? Something like this. So these are called truss. This is called truss, this type of structures. That the truss is always, in truss, the force is always axial. Either compression or tension. When we discuss truss, we will talk about that. Now, here, this is because of the end condition of between members, the fixed moment develops, here no moments develop. So this is a frame, this is a truss. Now, when you talk about the fixed and hinge, we will be discussing about when you draw the bending moment and shear force diagram after a few days back, after a few lectures. What happens? Very simplest form of structure is a beam. Very simplest structure of the beam. Beam means it takes the load, it takes the vertical load, so from that load like that. The simplest form is we have a hinge here and we have a roller support there. That means it is restrained against this direction. It cannot move this way, but it is allowed to move this way. This one is restrained movement this way and restrained movement around this way. This is restrained, but it is allowed to rotate. If you take a deflection, so it is allowed to rotate. It can rotate, allow, this is a theta, say. So hinge is, it cannot take any moment. The hinge is, so here what happens, when you restrain something, in structures, when you restrain some movement, restrains the displacement, then the forces develop, the reaction develops. So here there will be reaction if you do not allow to move this way, because the load coming in and you do not allow to move, because what is the purpose of the load? This load try to push it down, right? But you do not allow it to happen. So what happens? There is a reaction. It is the V, if it is considered A point and this is a B, so it is a VA, vertical upward, and there will be forces here. This is HA. These are the forces because you restraining. When you restrain something, when you do not like to let it go, what happens? The resistance develops. That is resistance. If you put something on a wall, something like that, it doesn't let me get inside the wall. So wall is pushing me back. That is reaction. Okay. Similarly, here is the H. The horizontal movement is there. So your restraint is this one. So it is VB. So how many unknowns in the reactions in the forces? There are 1, 2, 3. 3 reactions. Reactions equal to 3. And I told you when something is in equilibrium. Equilibrium, you understand that equilibrium? Equilibrium is there is no movement. It stays as is. It can take the load. So when you have a structure, a beam like this, it doesn't move anywhere, it stays there. It's equilibrium. There are 3 equilibrium equations. It is called static equilibrium equation. Static equilibrium. That means summation of, in a plane frame, it is summation of vertical force is equal to 0, summation of horizontal force equal to 0, and summation of moment equal to 0. These are the 3 equations. Okay? So what is the vertical force now here on this whole beam? If it is a P is the force. So P and VA and VB. VB and VA pushing up, P is pushing down. So together P, this is if it is up downward is negative. We consider in computer model, we consider downward is negative. Also, you know that I discussed that 3-axis. This is x-axis, this is y-axis, this is z-axis or z-axis. Along this is, I show you some arrows there, right? These arrows means the positive direction. X is positive this way. The arrows means it is moving. This one is positive. Y is arrowed upward. That means anything going up, upward forces is positive, and some forces in the z direction like this, z-axis parallel to this is, or z-axis is positive. So these forces is acting along the y-axis, but it is downwards, so it's negative. Okay? Then let's write it here. Negative P plus VA plus VB equal to 0. Summation of particle force is 0. Summation of horizontal force is, so suppose horizontal force, let us take another force, say Q. So this is a theta. So the minus, there's another force is coming into picture, that is minus Q. Component of this in the vertical direction is sine of theta plus VA plus VB equal to 0. Summation of vertical force equal to 0. Static equilibrium equation. The another is horizontal reaction. Horizontal force. Summation of horizontal force is 0. So what is the summation of horizontal force? This is Q into cos of theta, Q cos of theta. Now it is acting this direction, right? Because of this is the direction opposite to this x-axis. This is the x-axis. So it is minus. Then this is acting this way along the x-axis. So it is plus HA equal to 0. So summation of particle force is equal to 0, summation of horizontal force is equal to 0. Then what happens? The another one is summation of moment is equal to 0. Moment is already there. So summation of, if you take a moment about this is 0, moment is 0. So what is the VB? If the distance between this is L, VB, it is trying to rotate this way. Okay, so VB times of L, you see the equation of the moment is something like that. This is positive and this is negative. In moment case, clockwise from the right side, if you use the clockwise, so anti-clockwise, opposite to the clock, anti-clockwise. So it is positive, right side it is this way, clockwise it is negative. So this force is, if you take this force, you push it like this, so it is trying to rotate like that. If you this force, this is your beam, say you are pushing it like that, it is going like this. So this moment from here to here is L times VB. So it is positive. Then this force P, they are both acting at the same point. Say it is say L over 2 at a midpoint. So it is moment is this and this will try to create a moment like that. It is, I am considering from the right side, this is causing like this, so it is a clockwise. So it is minus P times L over 2, and component of Q in this direction, vertical direction, is minus Q sine of theta into L over 2. This whole thing equal to 0. This equation, VB L. So these two will not cause any moment. This force VA and VB will not cause any moment because it passed through the point and there no distance is 0. This force and the distance is 0. No distance. So something multiplied by 0 is 0. So these two forces will not cause any moment at this point. So only we have these are the moment causing forces. So we have 3 equations and 3 unknowns. So we can solve this type of beam. So this is called statically, there's a name there. Simply supported beams are statically determined structure. So you can easily find out these forces, and these forces because 3 equations and 3 unknowns. This is one equation for summation of vertical force 0, summation of horizontal force 0. This is the second equation. This is equation number 1. This is equation number 2. And this is equation number 3. So 3 equations, 3 unknowns, you can easily find out. So this is a statically determined structure. That means if we do a line diagram, how the simply supported beam is considered, it is in exam book you will find something like this. But actually it is not. There is another one is there. This is the hinge point. And force is suppose Q and P, this is theta. When we discuss bending moment and shear force diagram, we will discuss more about this. But one thing you should remember, this is called statically determined structure. It is called simply supported. Beam. You know that definition of beam, it takes the load along the length, lateral load. Loads are coming there. Typical example of the beams is your beam in a building, or this type of simply supported beam is more common in what? In bridge structures. In bridges, you'll see very interesting. I'm really excited to see the first time when I was working in a bridge design. I'm excited to see actually practically in the actual bridge they have got something like that. Hinge support. They make it like this. This is your roller support. This can look rock. And the other side, they make it hinge. This is roller, means it can move. And some places you will find exactly the roller like that. The plate is something like this, and you have got a hinge like that. And nowadays, we do not use that type of bearing. That's called bearing. They support the places where the beams are resting. Nowadays we have got elastomeric bearing. Beams are there. Elastomeric beams is the rubber bearing. It is made of rubber, some elastic thing. They are reinforced with the steel plates, and they are fixed and they are free here to move. Elastomeric bearing. Nowadays, nowadays the practice is elastomeric bearing. We will come to that when we discuss bridge design. Okay, so this is the example you see in case of the actually simple beam, and we need the simple beam in our bending moment and shear force diagram analysis. We will discuss that very soon. Now, another thing is that, as I told you, we have to find out the forces and deflection. These are the two very important items or important things we have to find out when designing the structure. To finding these two, forces means stress. Why the stresses is required? Stresses is always less than the yield stress. I discussed that. Our forces stress developed should be less. Our stress developed should be always less than F. F stress is less than Fy. This is the yield stress. Yield stress of steel. Why I am considering steel? Steel is widely used material in structural engineering. Because steel itself is used as a steel section, or steel is a part of a reinforced concrete. If it is under reinforced, mostly we design the beams and others as under reinforced, so that there is no sudden collapse of the concrete. Many of you know it. So there, the yielding, we prefer yielding. So again, there the stresses developed in the rebar, reinforcing bars should be less than the yield stress. Remember, I talked about the yield stress. You have got, it is very, very familiar drawing. This side it is stress. This side the strain. And this is your E value. Modulus of elasticity. So this is this, and this is your yield stress. In actual design, we make sure this is always less. And another important point is that in design, we do not allow the deflection is a one other criteria which determines the design, because we do not want the structure deflects or displace too much. Got it? So for that, what we do, we control the deflection. So when you control the deflection, the stress is further reduced. Suppose earlier for the strength design, the stress should be somewhere there. Because of the deflection control, it is somewhere here. Then sometimes we use extra members. Suppose our member may be safe like that. Because of this, we add another member, say. Here it is not that possible, but suppose if I have a truss member like this, I discussed that. If you have a truss, like that, it is safe. this type of structure is safe, but we put extra members to make it more. These members are redundant. If a vehicle, if the truss is used in, big trusses are used in bridges. So when a vehicle is moved, one vehicle is there, the load is directly goes there, some goes there, some goes there. All the members, it is a redundant structure. When the redundancy is there, then is less deflection. So redundancy also reduces the yield stress. So all the yield stress, so we are in a, when the stress is less than the yield stress, we are in the proportional limit. That means if you remove the stress, strain goes to zero. So this is called elastic range. So all our structural analysis. What are the structural analysis? We have elastic analysis. We call it elastic. Most of the structures we analyze with elastic analysis. The stress, we always consider the stress is proportional to strain. But there is another section where it was called plastic analysis. This plastic analysis is not much in use. We will consider only elastic analysis. That is, any analysis you do, metric structural analysis, finite element, is all linear structure. That means linear relationship between stress and strain. So one characteristic of elastic analysis, that means I told you in my earlier video, that means it is called, that means it's the proportionality. That means proportionality means it is, if you have superposition, it is called superposition. Method of superposition. Superposition means if two loads are applied, the deflection like that, this is equal to, if you have one load, apply this load, the another one, apply this load, superposition is like that. The deflection caused by, so suppose you want to find out the deflection in the middle. So deflection caused by this load, deflection caused by this load, if you add this together, this you will get this deflection. Similarly, the stresses also. It's the method of superposition. That is only possible because it is elastic analysis. Okay. Now, as I told you, the external forces developed, we have to counteract with our design. And that is the reason we need to do analysis. We need to know about structures, behavior of the structure under load. So that is why we need the subject called theory of structures. This theory of structures, what it does, it helps you to understand the behavior of the structure. That means you have to, if you want to know what is the deflection, you will find some equations, procedure, how to find the deflection, how to find the forces, how to find the reactions, how to find the stresses. So, theory of structures is your theory of structure itself. Then it comes, there is another called plates and cells also comes under it. Plates and cells. This is another subject. But that is also part of, that means it give you the theories for the behavior of plates, folded plates or cells, domes, etc. The another is your solid mechanics. how the solid behaves. Then also you have you know the structure called strength of material. This is also part of the theory of structure. Then comes your finite element method. Then matrix structure analysis. All this comes under theory of structure. Also the plastic analysis. So theory of structure basically deals with the theories. It helps you to understand the analysis. So in the analysis, our goal is to find two things. One is the forces or the stresses. Second thing is the deflection. The deflection or displacement. There are two basic methods. So when the structural analysis method deals with to finding the forces, it is called force method. There are two categories. We'll discuss that. Stress is proportional to strain. If you know the force or stress, you can find the strain. Strain is from strain, you can find the deflection or displacement. All these are connected. But if your main goal is to find the forces, it's the force method. Your goal is to find the forces only. The force method. The another is if your find is to go find the displacement, because once you know the force, you can find the displacement. You should know the displacement, you can find the force. These are intertwined. They can do that eventually. So if your goal is to find the displacement first, it's called displacement method. We'll discuss that, but displacement method is very popular for indeterminate structure. I will explain that. This is called kinematic indeterminacy and static indeterminacy. All this to come into picture. We'll discuss that. The force method is looking for forces. When the forces, unknown forces are less, then we go for force method. When the unknown displacements are less, then we go for the displacement method. That is why the displacement method, the complex structure has the less displacement than the forces in the members, so it will be easier to get the displacement than to forces. That's why we go for the displacement method. These are a little bit advanced. We'll discuss. We'll learn everything. Okay, don't worry. So this is all about structure. But one thing you should always remember: our internal resistance, Rn, should always be greater than the effect of load. And what we do, this is actually, if you call them nominal, we multiply by gamma, it's a load factor. And here we multiply by phi factor. This is called resistance. factor. This is your load factor. That means whatever the action from the loads coming in, whatever forces action is coming in, that means that is the member forces developed because of the external forces, the torsion, moments, shear, whatever it is, axial force, all we multiply by a load factor. This is, most of the time it is bigger than, and it is a summation means, why I put the summation, I equal to I to L, something like that. Why? Because this load, inside in a member, these forces, whatever, if you have your forces like axial, consider one example, axial forces, the tension compression. It is coming from dead load, one coming from live load, one coming from say wind load, one coming from say snow load. So all these, they sum up. But they sum up in such a way giving the worst effect. So we need to have a load combination. The code specifies how to combine the different loads, load combination. Load combination is determined, it tells you, the codes will guide you how to choose them. But the factors are also code gives, for different loads has got a different load factor. So once you have the forces, axial or compression, or the axial or bending or torsion, shear or everything, you have to multiply the factor. That is the total effect of moment, forces inside the member. So in a member, these forces develop some forces and that creates some stress, and that stress should be reduced lower than the capacity of the member. You have to choose the member size in such a way. Why? This value is phi is say 0.9, 0.85, this is less than 1. So these stresses are developed in such a way. This is actually the member capacity. You have to choose the member. If you choose the member size, in the design you do that. You choose the member size, so such that the stresses developed because of these forces is less than the actual capacity of the member. That means it should be less than, so your Fy times phi. This is the yield stress. Whatever force developed, it should be less than the yield stress. That is the region, is a function of Fy, Rm is a function of yield stress. So this is it. Always you remember, your member, whatever you determine by design, should always safe against the whatever is caused by the external forces. That is your design part. You should choose the member to counteract the forces. This is the analysis part. And the design part, they go together, hand in hand. Once you are sure that this condition is satisfied, all the members, all the components, this is higher than that, then you have a safe design. Also, what you have to do, you have to find the deflection. The deflection also should not exceed the limiting deflection. That means there is an allowable deflection specified by the code. It should not be more than that. That is all for today. We will be discussing more, and it is a good for me this whole thing recap, because I know where I am now. I can go proceed with the next chapter. Thank you very much. I appreciate for you to attending my class. Watch the other videos also. All the 5 videos, then everything will be clear. Thank you very much. Have a good day. Thank you. Bye.